Yeah, good morning, and thank you, Priyanka, for the introduction. So today's topic would be on smart devices or smart sensors, you may call it, for smart manufacturing. So I'm sure many of you in the call would have used sensors in your machines and in your processors. Now, typically in the conventional style, we just the sensors provide the status of our operations, and then we take this data to a PLC and use it for further processing. In this webinar today, I will be giving you some introduction on how we can, utilize these data, the sensor data, and derive some intelligent information out of it, which can be used for analytics, and this can actually by using this data in an intelligent way, you can actually improve the productivity of your machines and your operations. So now this is a typical, a familiar scenario for many people, working in the shop floor. Now, in the middle of the night, say if it is a 3-shift production facility, so in the middle of the night, say something goes wrong in your machine, so your production shuts down. So it could be a failure with a sensor or some other field devices. Okay, and I'm sure you all agree that the downtime is costly. And typically, when such incidents happen, the operators who work may not be experienced and qualified enough to handle the situation. So they would wake up the maintenance person in the middle of the night, and then a lot of time is spent in communication back and forth to understand the root cause of the problem and rectify it. And this actually affects the productivities. So this is a conventional way that we are utilizing our devices, and this is a common problem today in many of the companies. Now imagine if a situation where you are able to quickly diagnose the problem. Imagine if the plant floor data was working for you and making your life much easier. How would the situations look like? You would be able to save money, because every minute of production lost is actually costing you. So now let us look at a situation like this. So here, when a device is detected, and the automatic data collection engine adopts a device, then you get a default dashboard which is automatically generated in the Explorer view. Now this dashboard shows the key KPIs for the selected device, as well as the historical trends the system is collecting. The status, identity, and firmware information are shown when available. And then in the gray area at the top, you can actually see the results of the automatic analysis. So when a problem is found, a severity indicator is shown and a descriptive text explains what the issue is. So don't you think this kind of a scenario is more preferred and more productive compared to what we saw in the previous slide? So here you're able to get all the diagnostics data on a screen, and you're able to pinpoint and identify where exactly the problem was and what is to be done to rectify it. So you heard a lot about this, the connected enterprise, which is a Rockwell terminology for the Industry 4 today, which is getting more popular today, and many manufacturers talk about it. So at its most basic level, the connected enterprise is about enabling the equipment, machinery, and devices in a manufacturing plant and industrial operations, so that it is connected and it can provide the real-time information, as well as it can be controlled via an intelligent software. So this is how so it's about how you take a field level information up to an enterprise level. So your sensors are no more those black box kind of devices. Today the sensors can provide a lot of intelligent data which you can take up to your enterprise level, and then you can identify the root cause of the problems. You can do some predictive analysis on that information that you have, So when you talk about smart machines and smart equipments, so smart machines and equipment actually allow operators, to better leverage the most powerful element that very few organizations today are fully capitalizing on, which is the real-time data. Now, the traditional approach, which I showed in the beginning of my presentation, actually results in a low productivity because it doesn't efficiently use the data from the devices on the plant floor. So when you talk about smart machines and equipments, they provide unprecedented access to real-time data, so that can be turned into actionable information. Now, data can be logged and analyzed, to help workers make better decisions and ultimately optimize not only the equipment but the manufacturing process. So when it is connected via an open and standard network architecture like the Ethernet IP, you provide greater connectivity, so enabling real-time collaboration and data sharing upstream and downstream across all levels of an organization's enterprise. So that is the advantage of this kind of a connectivity by using the real-time data that you get. So the ultimate benefits that you get are, you achieve faster and more productive processes. You produce higher quality products at lower costs, increase the productivity, which is a very important criteria today. Then support the regulatory compliance. Then you identify and address worker safety issues. We will be seeing that more in the subsequent slides. And then optimize the supply chains. So building smart machines and equipments requires the right mix of technology, process, and people. So when you talk about smart devices, the slide here represents the various smart devices which are available in the Rockwell portfolio. So we have the smart sensors, we have smart safety devices, condition monitoring devices. Then we have the motion control devices and power monitoring devices. And the variable frequency drives and the servo drives are also smart enabled devices today. And all these devices can be hooked onto a network. So when we are talking about design, so we have an experience that we like to call the premier integration. It's actually experience of integrating the Allen Bradley smart devices into the Allen Bradley Logix control platform devices. Okay. So it helps the operation and maintenance people to actually, get a number of advantages. So when you look at it from a design perspective, you get the advantage of, automatically mapping of the data objects. So this can eliminate some of the address mismatches. From an operation perspective, you are able to, monitor the diagnostics remotely. So whenever there are challenges in the field devices, you can get those diagnostics displayed on your HMI or on a common computer. So this can reduce the unplanned downtime of the machine. Then we have the recipe control, we have the full access to the device data, the mobility is enabled. And from a maintenance perspective, when you look at it, you have something called as an automatic device replacement. So this is very important for the maintenance people. So whenever there is a fault in any of the field devices, when they replace it with the new product, they would have to do the teaching of that new product. But with the functionality of automatic device replacement, the teachings are automatically transferred from the PLC, the controller, to the device. So this can save a lot of time. Then it can help in the predictive maintenance. So through the analytics of the data that you get, you are able to do a predictive maintenance. You can predict which field device is reaching its life cycle, and you can plan a replacement of that product before the line stops. You can reduce the mean time to repair, okay, and you can have full access to the device data. So it's a more efficient use of the site personnel. So now let's look at a motor control, and let's see what has changed in the recent times. Okay. So now the trend that you see here is that the devices are being connected to the IP network. So in Rockwell case, it is the Ethernet IP, and they are all information enabled. So motor control and protection devices are now smart devices on the IP network, providing more information directly into the control and information systems. Now, the most important innovation of being IoT connected is that we not only get the status, whether it is on or off, but also the condition of the device, the motor and the thing that it is driving. So for example, like the amount of energy that has been put into the motor over time, which if trended, it will give us the condition of the device we are driving. Maybe it is increasing the load because the oil is not getting into the machine. So along with the integrated condition monitoring, we can monitor the mechanical health of the machine and predict things that will result in the stoppage or damage. So today we can now connect the motor control and protection devices for fixed speed motors, variable speed, motion control, and mechanical condition of the motor and machine. So all this information is available through the Ethernet IP into the controller, and this can be presented to the operator on the HMI. So IoT devices generate more information than a human can process. So we require information systems to provide us the dashboards of the machine process so that we can see that something needs attention. And then we can also delve down into what the cause is. And on top of that, today all this has to happen, in a safe and secure environment. So safety and security is another area which has to be addressed. So the aim of this slide is to focus on how important the motor is to the overall health and productivity of a manufacturing process. And controlling and protecting these assets intelligently increases the productivity, helps to control the energy costs and reduce the maintenance costs. So this slide actually explains the difference between a conventional hardwired motor system, control system with limited or no diagnostic information, and a Rockwell Automation intelligent motor control solution. So as you see there, some of the challenges in the conventional approach are highlighted. So let's talk through the issues and sometimes the hidden costs associated with the conventional system. Okay, and then we can see the highlights of the smart control approach, the motion approach. So so refer to the text on the to the motor and the yellow callouts. Okay, you see there to give examples of the type of information that an IMC solution provides. And how having access to such data helps our customers to be in control of the plant and the facility. So if you don't know what's happening to your plant, then how can you maintain productivity and the control costs? Then in this slide, let's discuss another type of intelligent motor control device, the simple overload relay. So a traditional overload relay's sole function in life is to protect the motor from overcurrent conditions that could cause damage. So if an overload condition were to occur for whatever reason, the relay would trip and the motor would shut down. So this protects that expensive motor asset, but now the line is down and we aren't producing the product. So then we send the maintenance team out to address the problem and get the line running. So so this sequence, if you look at, it's all a purely reactive maintenance. So how can we improve the situation? So a smart overload relay can dramatically improve the situation. So for example, the E300 overload relay, it sits on an Ethernet IP, providing enhanced runtime diagnostics to the Logix controller. So one really important piece of information that it provides is runtime current level. So let's say, for example, a bearing is wearing out and causing the motor to have to work harder and draw more current. So the system can now detect this problem before the relay even trips. So what that means is that the maintenance can be sent to address the issue even before it stops the production. So you can imagine how significantly this reduces the overall downtime, resulting from an overload condition. So the E300 provides a lot of useful, diagnostic information to help users proactively prevent or minimize the unplanned, downtime for critical motor applications. So we can have these customized, faceplate information. So you can see on your right side there, we can generate the red alarm bell. Okay. So this E300 provides a lot of useful information when the E300 trips on a trip or a warning event. The trip and warning status words, provide the real-time information for the reason of the trip or the warning event, which can be displayed in a SCADA system such as a FactoryTalk view. And this information can be used by the maintenance personnel to help troubleshoot the motor issue. So you can use up to 5 trip and warning events, are logged into the trip and warning histories, which are stored in a non-volatile memory. So maintenance personnel can use the trip and warning history information to see if any trends exist that could indicate, any more system-related issues. So these are the various warnings. So now let's again, go back to our first slide. So now let's again revisit this situation where, a line, stops in the middle of the night. Say, for example, a drive fails. So then the maintenance or person or the operator has to go to the shop floor, find the machine, find the failed part. Then, you have to have the spare parts on hand and can get a replacement installed. However, you're not the guy who's programmed the original drive. So you don't know where the correct files are, and and where in which PC the files are stored on. So these all can actually create a lot of delays. Now in this slide, what you see is something we call the automatic device configuration. So with the automatic device configuration functionality, the faulted equipment can be replaced and quickly brought back into operation, into production. So for example, so we have a drive that was damaged here. So after being replaced with a new drive, all the settings will automatically get transferred to the drive from the controller. So you can see how this automatic device configuration can be extremely relevant in time to repair, to keep the operations running. Now let's get into another section of this smart devices, which is the smart sensors. So, to truly be considered smart, a simple discrete or analog connection to the control system is actually insufficient. The sensor must be able to communicate more information than the simplistic traditional connections allow. So Rockwell automation, as you see in the slide, Rockwell automation accomplishes this necessary communication utilizing two information-enabled technologies. So on the left side, on the right, you see the one which is the Ethernet IP enabled, which is now incorporated into the higher-end sensors such as encoders, RFIDs, and code readers. Now the other information-enabling technology is the IO link, which you see on the left side of that architecture. So Rockwell automation now offers a wide variety of sensors on IO link, including proximity sensors, photoelectric sensors, temperature sensors, pressure sensors. So Rockwell automation has a distinct advantage in utilizing IO link because it is the only company that offers the controllers, IO link masters, and the IO link sensors. So this helps us to deliver a superior integration experience. So as you see here, in this architecture, we have the sensors and some field devices which are communicating over the IO link onto the Ethernet network. And then you have some of the other products which can directly communicate on Ethernet. And for the IO link products, we have the IO link master units, and then which are integrated with the controllers. So we are the only company that can offer this complete portfolio. So in this slide, what is shown here is the importance of sensors in today's manufacturing. So sensors are the eyes and ears of your machine. I'm sure all of you agree with this. So with an information-enabled connection to our sensors, manufacturers get a much more comprehensive view of their operations, as you see here in the slide. So the system can, often detect sensor issues before they become production issues. So with a traditional implementation, you would not know if a photoelectric sensor was, too dirty to operate properly, or an inductive sensor that was damaged. So there was no way to know until we had a production issue, until the sensor failed and the line stopped. And then through an extensive troubleshooting, eventually we track it back, to a dirty sensor. Now this results in a lot of valuable time wasted, which would ultimately be linked to the productivity, the production loss. Now an IO link enabled photoelectric sensor can tell the control system that it is dirty before this causes any production issues. So some sensors require different configurations depending on what is being produced. So for example, the registration mark sensors used in the packaging and labeling machinery typically needs to be retaught every time the label or the web material is changed in order to detect the new color combination. So what this means is that every time a label or web is changed, someone who knows how to teach the sensor has to physically go to the sensor and manually teach it. Now with an IO link enabled registration mark sensor, all the required configurations are taught during the commissioning and then stored in the controller. So whenever the label or web is changed, the appropriate sensor configuration for the new label is pushed down to the sensor from the controller. So no one needs to manually teach the sensor, for a simple label changeovers. So these are, great benefits that sensors can offer on IO link. So now, using IO link enabled sensors, it's a great way to make the system future ready. So this will be easier to show by representing the point IO, with a diagram here. So here you see we have a point IO in this. So as an example, we'll discuss an application, say that requires, for example, one pressure sensor and 4 discrete sensors. Okay. So in this application, say we use the IO link is used for the pressure sensor, and one photoelectric sensor, that is deemed particularly critical. So I have the pressure sensor and the photo sensor connected via and the photo sensor connected via the IO link. Now the other 3 discrete sensors are connected to the standard digital inputs, just like the conventional way you wire them. Now, after operating the system for some time, it is decided that it would be beneficial to get more information out of one of the discrete sensors originally connected to a standard discrete input. So as long as it is an IO link enabled sensor, this change is very easy. Now simply disconnect the sensor from the point IO digital input and then connect it to the master IO link master. So you see how simple it is. So the system update means that there is no change to the sensor. Now the sensor, whether you're using it as a discrete sensor or as a IO link sensor, the functionalities are built in the standard sensor. It depends on how you want to use it. So there is no change to the cable So no need for pulling new cables through the conduits or other difficult routing paths, because the IO link uses the same standard cable as the typical discrete sensor. Now the only physical change the user needs to do is to remove the wire from the digital input terminal base and insert it into the IO link base right next to it. So it's a minor wiring change. Now the system can now collect information from the sensor and configure it via the IO link. Furthermore, if all 4 of the channels of the IO link master were already being used, then it is simple to add an additional IO link master to the existing point IO rack. Okay. So altogether, by simply utilizing the Rockwell Automation IO link enabled sensors today, even when connecting these sensors to the standard digital inputs, an application can easily be updated to an information enabled architecture in the future. So it is like some kind of a scalability built in. So today you may be using the sensor as a discrete sensor providing the digital input. Now tomorrow, if the future systems demand that we need more information out of the sensor, then by simply changing the wire from digital input to an IO link input, you will be able to draw more information from that sensor. So now, even more critically, the premier integration developed by Rockwell Automation offers clear differentiation from the competitive solutions. So when using the competitive sensors, even with an Allen Bradley IO link master, see the incoming data is not labeled. So you can see here, you are able to get the data through the IO link, but then there are no descriptive tags on the data. So you are not able to relate which data is representing what. Now, in a complete Rockwell solution, the data is given name tags. So you see in the bottom part, so you can see the descriptive tags which actually indicate which data is representing what. So even though a user has access to all the data with either solution, when using the competitive sensors or the IO link masters, the control engineers must spend time reading the user manuals to determine which bit of data means what and how it is to be used. So by comparison, when a complete Rockwell solution is used, every piece of data is automatically given a meaningful name tag, and for every IO link enabled sensor, the same piece of information is given, the same tag name, and it is used in the same way. So this is a big advantage of the Rockwell Premier integration. It's easy to configure these sensors, and they seamlessly integrate with the Studio 5000 software of Rockwell. So now let's also talk about the smart safety devices. So as with the standard sensors, Rockwell Automation utilizes 2 technologies for getting more information out of the safety rated devices. So some of the higher end input devices now feature a safety rated network connection via the Ethernet IP. That is what you see on the right side. The devices can be directly hooked onto the Ethernet IP. So whatever you see highlighted in green, so the safety scanners, light curtains, the multi-access box. So these are devices which can now be directly hooked onto an Ethernet network. Okay. So this capability today exists in many of our safety devices and especially the ones shown there. Okay. And this network connection allows for information visibility and a dramatic simplification of wiring. So when you're directly hooking on a device to a network, you are saving a lot of wiring. So for example, if you look at the MAB SIP safety device, the first one highlighted in green there, if you were to wire it in the conventional way, it would have around 24 wires. But when I hook it onto a network directly, I save 24 wires. It directly sits on a network, and I can take all those data to the controller up to the enterprise level. So Ethernet IP is great for more advanced input devices. But at the same time, it can also be an overkill for simple safety input devices like emergency stops or interlock switches or the basic guard locking switches. So in order to enable an information-rich connection to these type of devices, Rockwell Automation is introducing a new terminology called guard link. So that is what you see on the left side of the slide. So the simple devices, which need not be hooked onto a network, so they can be wired using this guard link technology. And in the next slide, I will give you some insights into what this guard link technology is. So either through the guard link or through the Ethernet, you are able to take all this data onto a network, and you can transfer all this field level data up to an enterprise level. So this is what a guard link technology is from Rockwell Automation. So it is a PLE rated, a performance level E rated, safety rated series connection that enables enhanced diagnostics. Okay. So the safety logic device is able to collect information from individual devices. Now this enables the system to know which device is tripped and whether it is tripped or faulted. So imagine how much easier it will be to troubleshoot the safety system, when you can simply put a message on the HMI saying that a safety system is tripped. So say close door number 4 or select or clear the e-stop number 3 and reset the safety system. So this saves a lot of time. You are able to access, pinpoint and identify the fault, in seconds. So each interlock or e-stop is connected to a smart tab that you see there in red. So that features a local safety diagnostics. So what it means is that the series wiring does not degrade the safety integrity. So in a trunk or a drop topology. And the smart tabs are connected together in series using the standard 4-pin cables with M12 connectors. And furthermore, the same cable carries an unlock signal for any guard locking switches in the system. So the guard link master has an Ethernet adapter, making the information available to any network connected controller. So the Ethernet adapter is what you see on the left side, the extreme left of the safety relay there. So let's look at a scenario like this. So so I'm sure how many times many of you have seen the situation shown in this slide. So the door interlocks are wired in series to minimize the cabling costs. But in a traditional system, there is no way to know which guard door is open when the system is tripped. Now, because guard link can communicate to the standard control system which device is tripped, a message can prompt the operator as to where the open door is. So meaning the system will be back and running more quickly. So it can actually reduce your unplanned downtime, and it can help to improve the productivity of your machine. So now let's look at this scenario where you have a number of door interlocking devices and e-stops in a particular assembly line. So the safety devices are identified by numbers like 1, 2, 3, 4 up to 10. Now through this Premier integration, I'll just explain to you how you can achieve more productivity out of this machine. So as you have seen here, for each access point, through the risk assessments that we do in the beginning, we are anticipating some exposures per month. So for example, the access point 1, so the anticipated exposure is less than 1 per month or maximum 1 per month. But by tracking this the access to that particular area, we are able to calculate that per month the exposure was 2 and a 6-month average is 2.3. So by capturing the trends and by doing some analytics on the data, we are able to get this information, what is the current month exposure and what is the 6-month average. So what is interesting in this slide is, so if you look at the access point 7, so the anticipated exposure is say 1 per shift. So probably only 3 times somebody is expected to access that area per day. But if you look at the current month exposure, it is already 427. So what it points out is that somebody is accessing that area without any necessity. There is more frequent access into that area. So this kind of an analytical data can actually help us to investigate more as to why the operator is accessing that area more. And if you look at the access point 10, for example, the current month exposure shows 0, whereas it should be at least 1 per shift or 3 per day. So this is a clear indication that somebody has bypassed that safety access. So they are bypassing and using it, and that is why the current month exposure is shown as 0. So by able to pull out this kind of data and and by having some algorithms built around it, we can analyze them and derive some meaningful information out of it, which can help us to relook into this implementation, identify the gaps, and improve the scenario. So when you now look at the smart devices in summary, we can break it into 3 sections: the smart motor control, the smart sensors, and the smart safety devices. Okay, so these are all ways for you to better enable your connected enterprise. But earlier in this presentation, we also talked about the intelligent software and the dashboards that can present all of that plant floor data in a format that allows you to easily analyze it and react accordingly. So, but with the number of smart devices providing information, the detail and the sheer amount of data can be daunting. So that brings us to the analytics appliances, which helps you to choose only the data that you want to see, and the FactoryTalk software, which puts all the data in a context that can help you better manage your operation. So the use of the FactoryTalk in concert with the analytics appliance, the Shelby tool that you're seeing there in the middle, and the smart field devices provides features and benefits which are listed here. So ultimately, the data from the various smart sensors, safety and motor control products is harvested by the analytics appliance, which acts as the data access point for the software. So the FactoryTalk's analytics software is that window into the data or the plant or the process, providing visibility through computer or mobile device. So upon power up, the analytical appliance starts to look for devices on the local network. The user can specify what IP addresses to monitor and what parameters to watch. So in the future, it will be able to throttle the network traffic down if it is busy, accommodate different protocols. So the FactoryTalk then automatically pulls the data into easy to read dashboards, displaying user identified critical data, diagnostics, and the recommendations on the corrective and preventive actions. So for now, the FactoryTalk analytics for devices works with Ethernet IP devices with a varying depth of analysis that will expand over time. So while the system can provide basic diagnostic status information for any Ethernet IP device, we have a deeper analytical profile for 2095 Rockwell automation devices, and we'll be adding more continuously. So in future, we are looking to add protocol support for different kinds of automation devices based on feedback from our customers. So the result that you see here is a truly connected enterprise, which allows for gathering, analyzing, and sharing of real-time plant floor data between multiple functions and facilities for the optimization of manufacturing processes. Now, this smart manufacturing is made possible by the seamless integration of smart devices, controls, software, and the analytics. So that was on the presentation side. Now I will just run through some examples of the smart sensors. So these are, the audio-enabled animations. So you can also listen to the audio while these animations are running. In case, just to make sure that you are clear about it, I would also repeat once this animation is completed on what it is. So this is about the smart sensor. So please listen to go through this animation as I run it.
In this application scenario, a smart sensor's performance begins to deteriorate over time due to a buildup of dust on the device's lens. The sensor's low margin issue is communicated to the operator's mobility device. The information supplied to the operator also includes the sensor's location on the line. The operator can additionally choose to activate a visual indication, continually flashing the affected sensor's LEDs. This allows the operator to quickly and easily go to the device, assess the issue, and clean the sensor. After cleaning the sensor, the low margin alert is removed from the dashboard and no further alarms are shown. The benefit of using a smart sensor solution helped conduct predictive maintenance before the manufacturing line was stopped.
So this animation was an example of a photoelectric sensor that was implemented in a line. Now, as you know, the sensors degrade over a period of time. So in this particular example, there was an accumulation of dust or dirt on that sensor over a period of time. So all the sensors which were installed in that line are tracked using that mobility device, which actually shows the set point of the sensors, the location of the sensors. So whenever there is a degradation in the performance of the sensor, there is an indication on that mobility device as to the challenge is that sensor. It points out the position of that sensor, and then the operator can go there and quickly do that maintenance. And then once the sensor returns back to the healthy condition, the status would change on that on the HMI. So from a predictive maintenance point of view, you don't have to wait until the line stops. So the IO-Link technology will actually help you to understand when your sensor is degrading and help you to take a corrective action before the sensor actually fails. Now let's go to the next example here. So this is about smart commissioning.
In this application scenario, a new machine is installed into an existing production line. The new machine has pre-installed smart sensors that require commissioning. During the machine commissioning, the operator assesses all relevant sensor data on his mobile device. The operator identifies that sensor on channel 3 needs a set point adjustment. In the submenu, the operator is able to change that set point value instantly. Having changed the set point value, the operator can see the sensor dashboard adjusting to the required set point and that no further alerts are shown. Smart sensor solutions allow the monitoring of sensor signals and offer the ability to correct sensor parameters instantly. This can provide actionable data to help maximize overall equipment effectiveness.
So what you saw in this example is basically in an integrated production line, a section of the line is being replaced and replaced with a new machine. So the new machines already have the sensors integrated in them. And once a new line is integrated with the control system, all the settings of the sensors are transferred to the sensors automatically from the controller. Now on that mobility device on the dashboard, the operator was able to monitor the settings of the different sensors, and he noticed that one of the sensors require some teaching to be done to set it to the desired set point. And then he does the teaching, and once he has done it, all the statuses become green, and then he is ready to run the line. So now this is an example of a sensor replacement. Now this is a very common problem in production facilities. So especially in big production facilities where there are a number of sensors which are spread around various machines and conveyors. So whenever a sensor goes faulty, a replacement has to be done. So let's see this video on how an IO-Link enabled sensor can help in this replacement.
In this application scenario, a forklift driver reverses into the packaging line, damaging the smart sensor. The maintenance person receives a warning on his mobile device that there is an issue with the sensor on line number 2, conveyor 1. The exact location and additional sensor information, such as the sensor's part number and supplier, is available via the mobile device. Having this information, he knows which sensor to select and install from stores. After physical installation of the new smart sensor, the automatic device configuration function downloads all sensor parameters to the new sensor in milliseconds. The warning alarm on the mobile device is reset and no further alarms are present, allowing production to continue uninterrupted. The smart sensor automatic device configuration function helps minimize installation and increase equipment uptime.
So what you saw in this example was, a very common recurring, situation. So one of the sensors is physically damaged, and the operator has to replace it. Now, by having all these sensors wired through an IO-Link technology, the operator gets a message on his mobility device that a particular sensor is damaged. It points out and identifies which sensor it is, and as he goes deeper into that templates, he can see the model number of that sensor, and then and the moment he gets that information, he has to take a new sensor and go there, replace it, and the moment he replaces it, all the teachings of that particular sensor are automatically transferred from the controller to the sensor. So the operator no longer has to do any teaching. So even if that operator is not a skilled operator, he can still do that replacement without affecting the productivity. So now this is about an example of a product changeover. So this is again one of the a typical challenge in many of the food and beverage industries. So whenever there is a change in the product on a particular day, there is a product changeover, and whenever the product changeover happens, the sensors installed in that line have to be taught for that particular product. So now let us go through this animation and see how this IO-Link enabled sensors can help improve the situation.
In this application scenario, a bottling line has 4 different smart sensors installed, collecting a range of data points for production management. The current production run has an active recipe loaded for product type A. After a batch is complete, the operator performs a product changeover to product type B using his mobile device. New smart sensor parameters are instantly downloaded from the controller into each of the sensors. The sensor dashboard shows the new parameter settings and indicates production readiness for product type B. The automatic sensor parameter download function enables quick product changeover.
So what you saw here is that the operator on his mobile device, he is able to have all the recipes for the various product changeovers in them. So whenever he is changing a product and he selects a new product, he does not have to physically go and teach each sensor. The moment he selects the products, all the relevant settings related to that particular product are automatically transferred to the relevant sensors. So the big advantage here is that you save a lot of time. You don't have to be manually going and teaching each and every sensor. So this is a big advantage of this automatic device configuration. And this is about the smart tracking and tracing. As I explained in the earlier slide, now not all the devices need to be connected on the IO-Link. Some of the devices can also be directly hooked on to a Ethernet IP network, and we can directly take this data to the controller. So let's see this application, which is a track and trace application.
In this application scenario, a range of smart sensors are used for production tracking and historical trace requirements. For item level tracking, a high-speed code reader captures barcode or 2D code data and communicates this over the Ethernet IP network to the Allen Bradley automation controller, which in turn passes the information to FactoryTalk Production Center. For box tracking, the code reader captures the 2D code data on the box. This information is also communicated over Ethernet IP to the controller and then stored in FactoryTalk Production Center. Data capture of what product is on which pallet is also captured by a radio frequency ID system using tags mounted on each pallet. Information is captured on production data, lot numbers, or logistical data and communicated again over Ethernet IP to the controller and then passed up to FactoryTalk Production Center. All data is available for production tracking and tracing. All smart sensors are also integrated into Studio 5000 engineering environment, allowing configuration and management of all devices.
So in this example, we saw 3 devices being used. The RFID, which is the radio frequency identification system, which can, read. So the RFID, it can read data from the RFID tags, and the tags are reusable. So that is one big advantage of using an RFID, and all this data can be directly, communicated to the controller using through the Ethernet IP. Then we have the barcode readers. Now in barcode readers, through that you can read the codes, but in barcodes you can have only limited information, and again the codes are one-time printed. But still people use the barcode technologies even today, and the barcode readers can also be taken onto a Ethernet IP network and the data to the controllers. And then the third that we saw was the 2D data matrix system. So you can have a 2D data matrix coded on the product, and the 2D data matrix can have more information than a barcode. And by using the data matrix reader, you can read the data from that, and then you can use it for further use it in further algorithms and logic. So this was about the smart track and tracing applications. So in all these applications, the animations that we saw, you saw the operator was carrying a mobility device. Now it could be an iPad, or it could be your computers, your laptop computers. So whichever way, you can actually customize the information in the desired form that you want. And so in this particular screen that you see, even the picture of the sensors are shown there along with their cat numbers, the locations, the margin indications. So whatever data you want to monitor, you can have it in this particular format. And whenever there is any deviation in that data from the set value, the color would change to red, and it will flash, and you will be able to know that which particular sensor needs to be attended and what corrective actions need to be taken. And when I talked about the mobility in our Premier integration, you can also get this data flashed on your mobile through an SMS. So suppose you're not in your plant and you're traveling somewhere outside, and if something goes wrong with any of your sensors or your field devices, you can program the system in such a way that an SMS alert is generated on your mobile, telling you that there is a problem in a particular field device. And then, even if you're on the move, you can still call back your engineers in the plant and inform them to take the corrective actions. And once the corrective actions are taken, you will get an alert again on SMS that the problem is rectified. So, when we use the smart sensors from Rockwell, there is an add-on profile instruction suite which is available through our Studio 5000 software. So it will be easy to integrate these Rockwell IO-Link enabled sensors and Ethernet IP enabled products seamlessly through our Studio 5000 software. So that was all I had to share in today's webinar. I hope it was useful and informative to all of you. So now, if you have any questions, I am ready to attend to it.
Would request the participants to please type in their questions at the chat window available. The chat window is at right hand side of your screen. Please type in your questions.
Priyanka, for some reason, I'm